Hi everyone, welcome to my presentation. My name is Christian, product owner at ALLPLAN. My topic for you today is automation for structural engineers and rebar detailers. I have prepared 6 blocks for you. In the first 2 blocks, I would like to introduce you to the significant benefits automation workflows can offer to engineers and detailers. The third block will focus on the advanced reinforcement functions in ALLPLAN. In the fourth and fifth block, you will learn about solutions you can use to level up your automation. In the last block, I will show you the ready-to-use functions in ALLPLAN to elevate your work to the next level. But first, let me introduce myself to you. My name is Christian Virag, and I work as a product owner at ALLPLAN for team reinforcement components. As a structural engineer in the field for 3 years, my job was not only to calculate and reinforce, but also to innovate. This led to a journey where I'm always eager to find a better, faster way to achieve our goals. Over the years of working in an engineering office, I created 17 tools in ALLPLAN, and they all serve the same purpose: to make our job faster, simpler, and more reliable. After joining the ALLPLAN team, my mission is to continue with the same mindset of delivering automation solutions on a global level. Let's take a look at my example of a fully parametrical fixture. It is used to create weld plates for precast columns. With 12 individual controls, I am able to set up all necessary parameters of this fixture. This tool is still in use by more than 8 colleagues of mine, saving a lot of time on the modeling and enabling a more effective workflow. Now imagine how much time 17 tools can save you over the span of 5 years. So what exactly is automation? There are many answers to that question depending on who you ask, but if I were to summarize it, it would be: work smart, achieve more. It refers to the use of technology, in our case software, to perform repetitive and time-consuming tasks with minimal human intervention. This helps to increase the productivity and efficiency of the entire team, and the accuracy and the reliability of the performed task. Automation doesn't always mean the creation of a complete and precise result from a single line of description. Anything that makes the job of the user faster and more reliable can be defined as that. Remember the example of the weld plate from earlier? It is a form of automation. But of course, far more can be achieved in ALLPLAN, as you will see in today's presentation. Think about a task you do every day in the office. How many functions do you have to use? How many clicks do you have to make? If you were not able to count it with your hands, automation could fix it. The first topic of today is called advanced reinforcement. With these functions, users are able to reinforce elements with complex cross-sections in a matter of seconds without the need to define each and every bar path and placement. The first example is the extrude bar along path. This function allows you to extrude the defined reinforcement geometry in a cross-section along the full length of your element. Let's see it in action. Step 1. Create the cross-section. Step 2. Define the bar shapes. I already took care of this part. And finally, step 3, using the function extrude bar along path. In only a few clicks, I can create both the longitudinal and transversal reinforcement along my selected path. I can set up 5 different stirrup placements with a custom spacing for each of them. The other, more manual workflow would be to create each bar placement one by one and move them along the element to the correct position. The benefits of using this function can be measured in minutes. But of course, more can be achieved. Let's take a look. In this example, I have a model structure consisting of connected strip foundations and block foundations on top of concrete piles. All 4 of these strip foundations can be reinforced from a single section in less than a minute. As you can see, I have the reinforcement positions defined in this section. By selecting the path along the foundation's perimeter, they get reinforced as separate elements with the same stirrup placement options as before. This simplifies the whole job and saves me a lot of time by not having to copy, rotate, and position everything to the correct place. And of course, all bars and placements can be adjusted after creation. Our next function is sweep bar along path. You might be wondering what the differences between the two are. This tool allows for changes in the bar geometry. As you see here, my saddle beam has a change in height. You might think that poses a problem, but not really. Just take a look. It's all about selecting the correct path. The first steps are the same as before with a cross-section and bar shape definition. In step 3 and 4, I reinforce the bottom and top flanges by selecting the corresponding path. These bars have no changes in their geometry. In step 5, I select both the top and bottom path, thus indicating in which direction it needs to stretch. As you see from the results, the bulk of the detailing job can be done in less than a minute. The next topic for today is visual scripting. As the name suggests, it uses visual elements called nodes with which you can control the outcome. The different nodes are connected together to pass the necessary information from one to another. It allows users to create both simple and complex functions based on the needs of the engineer. They can create and modify 3D objects, add reinforcement, and assign attributes to them. Let's take a look at my simple example. What you can see here is a precast bucket foundation. Let's model it together. For an experienced ALLPLAN user, it shouldn't take longer than a few minutes. If you need to assign some attributes or special properties, maybe a couple of minutes longer. For me, it took about a minute and 10 seconds. Not bad, but of course, there is a better solution. Let's just open the library and select one of my previous scripts. I can reuse it over and over again in every project I work on. This function can be as complex or simple as I need, since it was me who created it. I even added a function to change the overall shape of the foundation from rectangular to circular in case the design needs to be reviewed or optimized. This step would be very time-consuming with the previous method without using the script. Our next topic is the ALLPLAN API and its capabilities. API stands for Application Programming Interface. It is the older sibling to visual scripting. It allows users to extend the capabilities of ALLPLAN, enabling them to create fully parametrical and custom solutions. This allows for quick and efficient iterations and adjustments to the architectural and engineering design. Imagine one of your state-of-the-art solutions. With the API, you can create the geometry with the same logic and ease of modeling as you already know from ALLPLAN. There are truly no limitations to the complexity, and the nice part is that it can remain fully parametrical. In case some additional design iterations need to be performed, it can be achieved via the palette or by directly modifying the model. A complex geometry often entails a complex reinforcement design. This can be done via the interface as well, using the powerful reinforcing functions you know from ALLPLAN. As with the model, optimizing the reinforcement design is easy to execute efficiently. To help you master all aspects of the application programming interface, you can visit our website, where you will find extensive guides on how to get started with your development. This website also provides a documentation of the available functions, with easy-to-understand examples on how to use them in your script. Let's take a look at the Smart Stair Converter, a solution to create and model precast stairs easily and efficiently. With a simple click, you can transform an existing 3-dimensional geometry or 2-dimensional area into a fully parametric stair model. If you choose to create a model without taking over any shape, there is a wide variety of parameters to edit and refine the geometry. It is also possible to set up the reinforcement fitting to the formwork even for complex geometries. And of course, all most common reinforcement arrangements are available to be used. The upcoming functions are also built with the same API. This allows for development to evolve and grow rapidly, introducing new features based on requirements and feedback provided by industry professionals. Our most advanced solutions to speed up and optimize design workflows are the automated reinforcement functions. Currently, we offer support for the most common and widely used elements for the cast-in-place concrete implementation, like walls, columns, and beams. To use them, simply start the function and select the desired object to reinforce. You will notice that after confirming the selection, the reinforcement preview appears, showing what the final result will look like. It is also updating in real time to give you visual confirmation of the performed parameter changes. I know in some situations identical objects are reinforced only once to make the workflow quicker. This, however, can introduce the possibility for user errors as the bar counts and quantities need to be multiplied by the element factor. The verification of bar collisions between structural elements is also impossible to perform in these cases, as the reinforcement only exists in one location. The automated reinforcement functions allow you to select identical elements together and reinforce them in one step. This ensures the accuracy of quantities and bar counts, but also helps make sure that no detail is left unchecked and unverified. If the provided parameters to set up the reinforcement prove to be insufficient, users can choose to unlink it. All created elements are reinforcement objects. This means that the same workflows apply to them as to manually created bars, enabling further customizations to the geometry and placement. In these cases, the automated reinforcement serves as a head start to individual modeling. In this example, you see me create the reinforcement in the real-life project of an elevator shaft. With a simple, multi-element selection, I selected all walls at once. At a later design stage, a different elevator supplier is selected. This means that the door openings need to be adjusted. An extra door was also added to the model to help with the accessibility of the elevator. With a simple activation of the wall reinforcement, I can adapt it to the new geometry without the need to edit the bars one by one or start the whole process from the beginning. To further speed up and optimize the engineering workflows, the mutual connection between elements also needs to be considered. Our first step towards achieving this was the introduction of the wall connection reinforcement function for ALLPLAN version 2024. The use of these two functions in conjunction provides the most efficient solution to handle the wall reinforcement. Using the same project example, you can see that modeling the wall connection can be done with relative ease. Currently, we are supporting the connection between two walls in an L or T-shaped arrangement with full awareness of the wall geometry, as you can see from the stirrups near the opening. Using the same example of the elevator shaft model, it took me 18 minutes to reinforce it from start to end using only the conventional reinforcement functions available in ALLPLAN. While they are powerful functions, it still takes a long time to model it. When using the automated reinforcement functions, the whole process takes only 1 minute and 50 seconds to achieve the same end result. The videos are sped up to be synchronized, but as you see, using automations is 10 times faster, which means I can achieve a lot more in the same time frame with less effort. To summarize my presentation, I showed you different solutions to enhance the workflow of structural engineers and rebar detailers. We started with simple but powerful reinforcing functions to shape and extrude bars in any cross-section. Then, showed you how to create your own automation tools and speed up the workflow with visual scripting and the ALLPLAN API. And lastly, the available automated reinforcement functions and why you should use them in your cast-in-place concrete projects. Thank you for your attention. My name is Christian Virág. You can find my contact information on the screen. Hope to see you again in the future, but until then, keep working smart to achieve more.